All right, so good afternoon, everyone. Thanks for joining the session. This is IBM zOS on Z15 hardware presented by Marna and Steve. Marna, Steve, thank you so much for presenting at this conference. So the stage is all yours now.
Okay, thanks, Anna, and thanks for putting this topic on the agenda. It's one of Steve and I's favorite topics to talk about, the latest software and the latest hardware. How great. So my name's Marna Wally, and you can see my email address here. I work in zOS installation in Poughkeepsie, and I am going to co-present today with Steve Warren. So Steve, you want to introduce yourself?
Sure. Hi, I'm Steve Warren, and it's always a privilege to talk to the GSC UK, and we're looking forward to this particular session. I work in IBM Garage for Systems, which used to be the Worldwide Client Experience Center. I'm an architect there, helping clients with solutions, and the vast majority of my career has been in zOS development. So we're excited about talking about this, and so we're going to kick it off, and Marna, take it away.
Okay, thanks. One thing to note, Steve and I do have a lot of slides to talk about in the next hour, so we have hidden a lot of slides so that we can get through all of the material, and we would prefer to take questions from the chat after the session is over. So we won't be looking at the chat just to make sure that we can get through all the slides. Okay. So what do we want to talk about? We want to talk about zOS on the Z15 and the things that you will need to do to prepare for that, the amount of functions that you'll have for compatibility. And then we do want to spend a good amount of time on exploitation, because if you're going to buy the hardware, you should probably use the great things that are on it. So we're going to talk a lot about exploitation. So let's move right into the functions and the features. So as you can see on the Z15, the model T01, which is the larger one that we released first, you can see a lot of the function and features that went into the hardware itself, the support that we had to implement within the zOS stack to get you those benefits of having an entire stack aligned for the efficiencies that you need for your applications and your workload. We put that support in here in blue. So you can see that there's a considerable amount of zOS support that we had to put in order to support the Z15. As you know, we have periodic refreshes of the hardware. So after the first GA1 of the Z15 model T01, we came out with what we called GA1.5. And those were the items that you can see in red here. And then most recently, we have come out with GA2 support for the T01 that you can see here. So they're on the lower left, a couple of more additional enhancements. We look at the smaller machine. This is the Z15 model T02 that came out in about the GA1.5 timeframe for the T01. So you can see again the support that we had to put in for the T02, and then also the GA2 support, which came out on the model T02 very recently. Okay, so let's look at where we can run. Releases of zOS will run on the Z15, T01, and T02. So you can see here that we will support zOS releases down to zOS 2.1, but understand that zOS 2.1 is out of service, so you will require an extension so that you can be supported on the T01. The PTFs did close and they're core closed for zOS 2.1 for the Z15 support. So you can acquire the fixes anytime you want. It's just that if you need support, you need an extended service contract. And then subsequently, zOS 2.2 did go end of service rather recently. So if you did want to run zOS 2.2 on a Z15 and you required support, you would be required to have the end of service contract. 2.3, 2.4, perfectly great to run on a Z15. I did want to note here that some new information on the Z14, it's going to be withdrawn from marketing September 30th, 2021. So what releases you're running of zOS on the Z15, the capabilities that you have will really differ based on what you have on the release. Like I said, zOS 2.1 is going to have toleration support. So the PTFs will be closed, but you really have nothing more than toleration support if you choose to run a 2.1 on a Z15. Now for exploitation support, what you'll see aligned on the Z15 and the zOS system, you'll have some exploitation support on zOS 2.2, but it's just for some selected function. It's not the full gamut of exploitation that you'll see. 2.3 has a lot more of exploitation support that we have for the z15, and then 2.4 is the whole thing. So if you're running your latest release of zOS on the z15, you will have full range of all of the exploitation items you can use. And then if you go back to the 2.3, you'll have most of them. 2.2, you'll have a lot less. And then 2.1, all you pretty much can do is have toleration support for it. So set your expectations accordingly. So one of the most important things we have are the PSP buckets, and the PSP buckets, we have identified the necessary service. But what we've done for Z15 is a little bit different than what we did for the Z14. In Z14, we had long listed all of the specific PTF numbers and then also identified them with the fixed cat. What we did in the Z15 was we cut the cord here. What we did is we said, we're only going to document the fixed cats, and you must use those fixed cats to then go identify the PTFs that you need. Again, if you know anything about fixed cats are wonderful because we let SMP do all the heavy lifting and let SMP do the identification of the PTFs that you're missing and that you don't yet have installed that are applicable. So rather than going through and listing every PTF in the bucket for Z15, we're going to let SMP do that, and we'll only identify the fixed cats that you need. So what do you minimally need? You minimally need the PTFs that are identified for base support, which are these two fixed cats that you can see here. If you're going to run the T02 server, you will need to run the T02 required service fixed cat and also pick up this Z15 8561 required service fixed cat as well. So you'll need to use both of these. And again, no exploitation, it's not required, but if you're looking at exploiting the functions on the Z15, which I strongly encourage you do, these are PTFs that are defined with the exploitation fixed cats. And then finally, for recommended service are defects that we found, other customer defects that we found that we want to tell you about. And those are listed in the recommended service fixed cat category. And those you will see automatically put into by PTF level into the PSP bucket itself. Okay, now web deliverables. We always talk about web deliverables because that actually provides to you some of the function that you'll need if you are interested in fully exploiting the CryptoExpress 7S. So we do need the ICSF, the zOS ICSF function, in order to exploit that latest level of CryptoExpress 7X. That arrives to you in a brand new FMID called HCR77dog1. The name of that web deliverable is the cryptographic support for 2.2 to 2.4, meaning you can install that FMID down to 2.2, 2.3, and 2.4. However, HCR77dog1 FMID is not shipped in zOS 2.4. So when I said you get the latest functions and all the exploitation stuff for 2.4, well, it's only if you go and pull this web deliverable and install it yourself. And you can see the web page here on where to acquire that from. Hopefully you're familiar with the way that we run SMP report missing fix, and given that we do not document individual PTFs anymore in the PSP bucket, this command is incredibly important now. So number one, make sure you have the latest and enhanced hold data, because that will provide to you the latest fixed cat information, of course. And then you can see here at the bottom of the slide a very simple example of the syntax you would use to have SMP invoke the report missing fix. Notice here that on the fixed cat, I have used a wildcard so that I will pick up the Z15 T01, T02. I will pick up recommended, required, and exploitation. It's a great thing to do. All you're doing is running a report. You might as well go see what all kinds of fixes that you are missing do on here. Once you run that command, here's just a very good example of an SMP report that you'll get produced. Hopefully you've seen this one a lot. This was run against a zOS 2.4 system. And just an example, we have a couple of exploitation fixes that are missing, a couple are recommended, and we have several required fixes that are missing. And SMP is so good as to also tell you whether it's been received or not, and if it's a good fix, meaning that it's not PE, which is helpful. So now let's move on to the upgrade considerations. So in general, you know, the zOS release that you're running doesn't absolutely require a z15 T01 or T02, but, you know, do recommend that if you run on the higher level of the hardware, you'll have more functions available to you and more advantages that you have running on the higher software. We really only require, if you're going to put zOS on a z15, the minimum, the absolute minimum is that you just put on those base or required fixed cats. You don't have to put on any of the exploitation items if you don't want to. But again, as I said, it would be nice if you could at least run a report, see what you're missing for exploitation. And if those are convenient to put on, of course, that would be a recommended thing to put those on as well. We do recommend, as always, that you, when you're migrating up an upgrade level of the hardware or even an upgrade level of the software, that you do the changes in small batches so that you can just introduce a change at a time and then stabilize. And if you back out if you need to, and then continue on with the next one. Also, it's good practice to keep members of the Sysplex generally at the same software level so that you might reduce any of the functional disparity that you might have. Of course, you can keep them at the different levels. We totally support that, but just for long periods of time, this is probably not something that you would want to do. Also, make sure that you look at the restrictions and the upgrade considerations when we're giving you the upgrade planning information during this presentation. Okay, so speaking of the upgrade information, there is no migration book for the Z15. As you might have known, for zOS 2.4, we removed the book and we replaced it with the zOS 2.4 upgrade workflow. We really want you to use zOSMF. We really want you to use the workflow. That's where we've put the upgrade information. The same thing is for the Z15 server. We put the Z15 zOS upgrade information into the workflow. So it's incorporated and embedded right into the 2.4 upgrade workflow. But we also separated it out into its own Z15 workflow, and it's a really small workflow. And so that is available if you just wanted to look at that particular workflow. Let's say you're not interested in upgrading to 2.4 right now, you could just get the small Z15 workflow. Now, for those of you that don't have zOSMF, that's totally fine. We have exported that workflow so that you can see it in a single flat file, and you can do searches and printing on it without zOSMF. And you can see the link in your presentation here where that's been provided. So we do recommend that you use the Z15 workflow within zOSMF itself, but if you don't have zOSMF, you can still buy a Z15 and you can still get the information. You'll just have to pull it from the exported format from Knowledge Center. Okay, so let's look at some unsupported hardware features on the Z15 that you can't order or carry forward. So you can see here that this is the list of the items that you will not be able to have on the Z15. Okay, we'll talk a little bit about ZEDC Express specifically coming up in a little bit. As always, when we have a new machine, we have new machine instructions. As we have new machine instructions, we don't want them to collide with any assembler macros that you might have coded as well. So we're worried a little bit about collisions there with our new machine instructions. So as always, we want you to review the tech doc that you can see listed at the bottom here. And there are various ways where you cannot have the mnemonics and the machine instructions collide. This is something that happens every release. If you go to that Washington System Center flash at the bottom, you can see a list of the complete machine instructions that are available on the Z15. For IOCP, okay, we provided support in IOCP in order to do the base machine definition, and this will also include the definition of the NCS1 LPAR, which helps with doing dynamic IO configuration on standalone coupling facilities. In IOCP, we also added support so that we could increase the coupling chip bits per KEK and also increase the number of coupling facility links that we could have. So as you know, IOCP is the same FMID it's been since before I started IPM. This is one of the oldest FMIDs I know. And we have PTFs that are available for it, and the PTFs have been identified as base support. Also for HCD, there's no surprise here. You'll need some HCD APARs for base support for the Z15. This is necessary because we had to add support for HCD to do a higher machine definition and also to allow it to be, the IODF to be activated. As I'd mentioned before, the MCS1 LPAR, which helps with doing dynamic IO operations on a standalone configuration, has been incorporated in HCD. And like IOCP, we have the definitions in HCD to increase the coupling chip bits per KEK and also the CF links as well. The APAR that we have for HCD has been considered base support, of course, and so you'll need to make sure that you identify that APAR has been coded with the fixed cut that you'll need. Okay, so now we'll move on to Sysplex. Let's let Steve cover Sysplex.
Okay, thanks, Marna. So when we're talking about moving a new box into our Sysplex, IBM has had some long-standing rules about interoperability between levels of CPCs or KEKs that can be in one Sysplex. And so the Z15 will work with N-2 levels of hardware. So that means that the Z15 will be able to fully support in the same parallel Sysplex with a Z14, either the large or the smaller, used to be called business class size machine, ZR1, as well as the Z13 and Z13S. And so it can participate, but only when you have the links configured correctly, which we're going to talk about on a subsequent slide. So we can just move to the next slide. So in the upper part of this diagram, we have what you may have at your shop today. You may have a combination of ZEC12, Z13, and Z14. And now I want to bring in this new Z15, either the T01 or T02 box. And guess what? Because of that, what I just said about the N-2, the Z15 is not supported to be able to be in the same parallel Sysplex as a ZEC12 or ZBC12. So you're going to have to roll that one off the floor when you move your Z15 in. Now, that being said, when you actually are going to try to do the coupling links between these machines, you're going to need to make sure that things are configured correctly, and that will be a segue into the next slide. So for the last number of years, IBM has made a statement of direction that said that the last machine that will support the InfiniBand short range or long range devices would be the Z14, the big machine. I refer to it as the mother machine, and then the baby machine is the ZR1. But that was the last machine to support the InfiniBand links. Even the Z14 ZR1 only supported the two devices that are listed here, which is the ICA SR device for short range and the Coupling Express long range device. And so there's no surprise that with the Z15, just like the Z14 ZR1, that these are the only coupling devices that are supported. So how do I configure that in my system, in my Sysplex? Well, you can still use the InfiniBand as long as you're not talking to a ZR1 or to a Z15. So if I have a Z13 or Z13S communicating with a Z14 or a Z14, or Z13's talking with one another, or a Z14 mother machine talking to one of those, that's perfectly fine. And so you can see above the green and the purple where the InfiniBand is still in play in this new parallel Sysplex. The difference is that it is not talking to the Z15 or the ZR1 using those InfiniBands. So This chart has been around for quite a while, and this should not be any shock to anyone. We've tried to give you ample warning that this is coming. And so you can creatively still use the InfiniBands as long, again, as you're not communicating with these upper level machines. Like we always tell you to do, in addition to doing the zOS software that Marna talked about, it's also good, of course, to update the firmware levels for those that are in the parallel Sysplex. And so for the z14 and z13, we have recommended CFC levels that you're running with, the service levels for those, and as well as the driver bundles and the MCL numbers to be able to ensure compatibility between all the devices that they're in your Sysplex. All right, now we're going to just dive into exploitation considerations for selected functions. And there's a whole slew of them that we're going to be talking about here. And I'm going to be talking about the first one, which is the CFCC level code, and then we'll dive into some of these other ones as well. So like any new level of hardware, we usually come out with a new CF level, which is critical to be able to support sometimes new features of the hardware device, and also to provide enhancements in availability, resiliency, et cetera, with the coupling facility. So like we recommend in any time you're upgrading to a new CF level, we recommend that you use the CF Sizer tool. Here's the link that's provided, to just make sure that you're going to have enough storage to be able to handle that. So sometimes the storage requirements change when you move from a CF level to CF level. So this is business as usual when you're migrating to a new CF level. The next thing you're going to want to consider is the fact that there are a number of different enhancements which are made, and most of them you don't have to do anything with, that they are internal improvements. Of particular interest, we'll talk about the two at the bottom. I'll talk about all of these on my Thursday session, which is parallel Sysplex update. So if you don't have plans to go to that one, I encourage you to check them out. I will talk in more detail. But suffice it to say, let's talk about the last two. The third one, it says shared engine default is dyne disp equals thin. And now, because there is now an interrupt mechanism, request for a non-dispatched CF will be picked up sooner. And before, the default was not dyne disp equals thin. So now if you have a shared engine for your CF, now will now be the default setting for dynamic dispatching, just because the performance numbers have been so overwhelmingly good for dynamic dispatch that we've made this now the default value for that. And then the last one I'll mention, which was part of the GA 1.5 of the Z15, was the CF monopolization avoidance. And in essence, what this is that if one particular structure is monopolizing all of the CF resources, the coupling facility now will notify zOS, and zOS now will attempt to throttle back the usage of that structure, or to queue some of those requests to enable other folks using other structures to have fair access to the coupling facility and their structured data.
Thanks, Steve. So I'll briefly talk about a hyper dispatch enhancement that we have. So this is concerning a hyper dispatch and trying to get better performance when LPAR weights are changed by you. So currently the processors we have enabled for IO from the highest configured CPU to the lowest configured CPU. However, when you do an LPAR weight change, it's going to cause the IO-enabled vertical highs and mediums are going to be converted to vertical lows and then immediately parked with hyper dispatch. So what we're going to do in Z15 is we're going to change the order around and reverse it, the number of processors that are, or which processors are enabled for IO interrupts. So SRM is going to set those IO interrupts for the lowest configured to the highest configured CPU, so that if an LPAR weight change did happen, that the vertical high and the vertical medium processors will remain enabled for IO interrupts. this function was rolled back to 2.2 and 2.3. So this is one of those exploitation functions you'll have all the way back to 2.2. Another enhancement that we have in zOS, and this is only going to be for zOS 2.4, is that SLIP has been enhanced so that we could monitor an range or a particular address to look for a key change. If we see a key change for a particular address or for a range of addresses, we could take a diagnostic action that you decide on, such as, dump or trace. So all of this is done within the SLIP command options enhancements that were added. You can look at them in the command reference book. And so you can see here an example of what you want to do to enable it with the new options or disable it with the new options. As always, we have new counters, new sampling for hardware instrumentation services within the CPU measurement facility. So as with every hardware, we have new extended and crypto counters, and we also have a new sample type as well. This support was rolled back all the way to zOS 2.2. So this is another example of an enhancement that you'll have for all the way back to the zOS 2.2 system. Remember, if you're going to gather these new counters or take these new samples, you will have to have the HIS address space set up. So in order to do that, you can look at the publications that you see here on how to set that up. Now a word about C, C++. Of course, we have the new machine instructions on Z15, and the C, C++ compiler has taken advantage of certain of those Z15 instructions. You can see a short list listed here for them. Vector Enhancement Facility 2 probably might be one of the most popular ones. But the way that C, C++ has delivered its support for the Z15 is it has put it into a new level of the compiler. The new level of the compiler has been packaged into a new FMID. The new FMID has been put into zOS 2.4, and then the zOS 2.4 FMID has been put available on the web for you to install on your zOS 2.2 or 2.3 system as well. So we did something a little bit different with the compiler here in that we didn't roll back the support on the 2.2 and 2.3 system with PTFs. You got to go get the FMID. The FMID is already in 2.4, but you can roll it back. So you would have to install another web deliverable in order to have the latest C, C++ compilers to make it architecture and tune level 13 in order to support the latest Z15 in machine instructions. Now, I just wanted to show a quick slide here of some of the cryptographic support enhancements that we've added in Z15 GA2 and also T02. These were the latest ones as we had of August. So you see there's a considerable amount of CCA enhancements, both for the AES standard processing, more data encryption enhancements with new algorithms, and there's also a new ECC curve associated with Bitcoin if that is interesting to you. Also, we have cloud crypto enhancements for EP11, and if you're a user of the IBM Cloud HyperProtect crypto services and interested in key management, this will be something that's particularly interesting for you. Going back a little bit into the GA 1.5 level of the Z15 and the introduction of the T02, I just wanted to throw out an advertisement on the Crypto Express 7S for quantum safe signatures. This is a big important area within security so that we can actually sign particular pieces and use quantum safe signatures so that those signatures will remain secure even into the age of quantum you can see here. Okay, Steve, you want to talk about ZCX?
Yeah, so of course, ZCX is an exciting new component on zOS starting in 2.4 and can run on the Z14 GA2 and higher. And one of the new technologies that it leverages is, well, it leverages an existing technology, which is the inbound work queuing for ZCX. So already on an OSA Express card, there is a concept of inbound work queuing. And there is a new ancillary queue that is designed for ZCX network traffic. And what the inbound work queuing really allows you to do is to segregate traffic coming in on your OSA Express card. And so by separating the traffic that's destined for ZCX as opposed to traffic that is to native zOS traffic, allows for really three benefits. One, it allows for parallel processing of the data coming in. zOS native traffic and ZCX traffic can be processed in parallel. It can keep shorter inbound TCP/IP queues very short for that ZCX traffic. And then lastly, because you have that segregated traffic, that TCP/IP inbound processing that is for that ZCX traffic is zip eligible now. And so now you're able to run that with not affecting your 4-hour rolling average in terms of the TCP/IP processing for that ZCX traffic. So what do I need to enable this? I need, first of all, an OSA Express 7S or 6S, and this will run on a Z14 GA2 or higher. You need zOS 2.4 with a couple of PTFs installed. From a comm server perspective, I actually need to enable IWQ. If you already have IWQ enabled, there is really nothing else you need to do from a configuration perspective. But if you have not done it, you'll need to add this workload queue subparameter for your OSA Express QDIO statement. And last but not least, when you start up a ZCX and that DVIPA is activated for ZCX, it will automatically then leverage this IWQ support. So cool stuff for ZCX.
Let's move on to the data compression functions of the Z15. So as you recall before, prior to Z15, we had a ZEDC PCIe attached adapter, and that was a priced feature. On the Z15, we've got some great news because on the Z15, we have the compression capability, and that is right on the chip now, and you don't have to purchase the ZEDC adapter anymore. That's why you can't carry it forward if you look at the chart from before. So with it now on chip, we can have all of the zOS APIs for both the authorized and the zlib go through and use this data compression that's right on the chip. So the support for exploiting this new capability on the chip, and it's called the NXU portion of the chip, is rolled back all the way to zOS 2.1. You don't really need any toleration support because it was done in a perfectly compatible and transparent manner. So one thing to note about, if you've compressed the data on the old ZEDC, like on your Z14 or before, and you want to decompress it on the Z15 using the NXU, that's on the chip for the Z15, totally compatible. If you've compressed it on the Z15 and you want to decompress it on the Z14 with the ZEDC, that's perfectly compatible as well. I did want to mention on the next, or maybe here as well, if you have to do if you don't have the ZEDC adapter on the pre-Z15 and you have to do that software inflate, and this is all in software, you know that those are expensive machine cycles. So you'll just want to take into consideration where you do compression and decompression if you are going to rely on the software version of the inflate because you don't have the ZEDC adapter or you don't have a Z15 on those other systems where you want to do the decompression of it, okay? So just keep that in mind. That's always a consideration as it was before, and it just continues on with the Z15. So for data compression, what do we have for the NXU on the chip? Well, it's on the Z15, T01 and T02. You'll need a PTF installed to support zlib, okay? And there's some description here about what will happen if you don't have the zlib PTF on, but just put the PTF on. It is considered a required fix for the Z15, so you should have it on. Another thing I wanted to note for you from an upgrade point of view is we have the IQP PRM ParmLib member, which controls PCIe type of configuration information. Inside of that ParmLib member, we have some different defaults between the Z14 and the Z15, all related to the NXU being on chip for the Z15. So you might want to take a look at that. Personally, I think these defaults are very reasonable, so I would just go with the defaults and being that they are different between Z14 and Z15, and dynamic being on which system the zOS runs, you will have different defaults. If you have an application that uses zlib, you don't have to have read access to the SAF class that you see here, so you can remove that in order to clean it up. Also, for data compression, you might want to provide a usage estimator if you haven't used it yet. Where do you find that? The ZBNA tool. Where is the ZBNA tool? You can see it here on the link here. So the ZBNA tool has been very useful for calculating many, many things, encryption, compression, and you'll see a minute in sort as well. So the ZBNA tool is becoming very important for many reasons. And here's another one, the data compression. Now, as I'd mentioned before, if you can transparently fall back between the hardware, you can also can't transparently fall back between your applications that are using it, but do notice that if you're going to use the software inflation, those will be expensive MIPS, so you want to take that into consideration. From looking at the performance for the compression, the ZEDC is not PCIe attached on the Z15, so the RMF reports that looked at PCIe attached performance numbers are not going to be valid anymore. You're going to need to look at the RMF EADM report for that instead. So the information is just moved from one report to another for the compression capabilities in RMF. This is one of my favorite charts where we talk about the differences between Z14 and before and the Z15. And I love this chart because it also explains clearly how the zOS priced feature that happens to be called ZEDC is coming into play. So on the left-hand side of this chart, you'll see before Z15, we had a chargeable hardware feature that was called ZEDC. And we had a chargeable software feature that was called ZEDC. And you had to have both the priced hardware feature and the priced software feature to use the long list of items that are on the left here, okay? So you had to really pay for it twice, pay for it hardware, pay for it software prior to the Z15 in order to get compression for all of these exploiters here. Now let's move to the right side of the chart, which is the world now of the Z15. So in the Z15, I think things get a whole lot easier. There is no hardware priced feature for compression anymore. Like I said, it is on the chip, it's the NXU portion of the chip. There's no charge for the hardware feature. However, we still have remaining the zOS software priced feature called ZEDC. But now what we see is a split of which exploiters need which side of it. So for the asynchronous authorized exploiters, and you can see those in green here, and I put it in green because those are the ones that need the priced feature for zOS. So if you're using SMF logstream or the very popular HSM DSS compression, those functions need authorized asynchronous exploitation of the compression on the Z15 chip. So you will have to pay for the zOS ZEDC priced feature. However, look at the other side of this. If you're an exploiter of using zlib, which is an unauthorized and synchronous exploiter of compression, and there's a lot on that list, those are ones that you get for free. So let's just say you're as an example, you're a customer that, let's say, the only thing you're doing for compression is Connect Direct. If that is the case and you don't want to expand to use any of the other exploiters on the green list, you do not have to pay for the ZEDC zOS priced software feature. So look at this chart. I think it's a really good chart in trying to explain to you what you need and how it interacts between the hardware feature and the software feature. Okay, that was compression. Let's move quickly on to sort. Sort, this is new news here. So standard on the Z15, we have one sort accelerator per core, and that new CPU coprocessor can be exploited by using a brand new machine instruction called sort-L. And IBM products have two exploiters of the sort-L instruction. We have df-sort, which is no surprise there. If this is a sort, coprocessor, we're going to want to use it in df-sort. And also we have another one, db2 for zOS Utility Suite. Those two products need PTFs in order to install so that you can use the new sort L instruction with the Z15 coprocessor that we have. Now, how much benefit are you going to get? Well, where do you go? You go to the Z batch network analyzer, because it seems like that's where you go for everything nowadays. But there is a new application within there called the DF sort Z sort, which you can look at data from your current environment, even though you don't have a Z15, and you could identify with ZBNA how much the advantage would be if you were to use the DF sort with the sort L instruction associated with it. Now, why do we have this? What's the benefit that you're expected to see from it? It's intended and designed to cut the CPU cost so that your batch windows can have reduced elapsed time. Also, we think that this will help improve selected database functions such as a reorg that you might have to do. So this is a really good thing. Okay, so Steve, why don't we take it away now for the large section of System Recovery Boost, one of the best functions on Z15.
Okay, thanks, Marna. Lots of cool functions in Z15. And so arguably the flagship deliverable in the Z15 in terms of functionality has been this thing that's called System Recovery Boost. Introduced in the GA1 when that came out last year. System Recovery Boost is really cool. And we'll talk first about the first deliverable as a recap for some folks may not have even an understanding of what the first deliverable is. And then we'll talk about the stage 2 support, which allows System Recovery Boost to handle a different set of boosting opportunities on the platform. So the idea with System Recovery Boost is to restore and recover workloads substantially faster by using additional resources and processing capabilities on the Z box without having any increase in your software licensing costs. And so this is really cool. So in the first iteration, it was focused on a re-IPL of a system. And so with System Recovery Boost, you could leverage some additional capabilities, which we'll talk about in just a moment, to actually have a faster shutdown. You could accelerate your image shutdown in preparation for a planned shutdown action. So by invoking a simple proc to kick off your shutdown, you would have accelerated shutdown of your box. And again, an effort to try to minimize a disruption when you need to re-IPL a machine. The elapsed time is compressed, meaning that you have less downtime, you have less backlogs, etc. All of this is in that scope. So once the shutdown has been accelerated, then in addition, if you go to the right, faster GDPS automation actions. So GDPS scripting and actions that are taking place as part of reconfiguring and recovering your environment quicker are also going to be accelerated with this new recovery boost. Thirdly, there is a faster startup. So when I'm IPLing my zOS image, I'm going to be taking advantage of this boost in the performance of and reducing the time window that it takes for me to recover both the zOS operating system as well as your middleware environments, and then also even applying to your client workloads, and to allow you to even have time to be able to catch up maybe workload that has been backlogged because of the outage, that either planned or unplanned outage that you were experiencing. And again, like we just mentioned before, the workload catch up. So it's anticipated that the amount of time that they have for the boost would be enough that all the operating systems would have already recovered and all of your middleware and your applications are up. And now I can start digging into that workload that may have backed up for a while. So again, System Recovery Boost allowing the hardware to give you additional resources without you paying for it. So that's all good news. And so let's go to the next slide and we'll just talk a little bit more about that. So let's look at the right of the screen here. The left is kind of a summary of what we just talked about, but the right talks about the different kinds of boosting actions that can take place and different types of boosts that can occur on your system. And notice that it even supports other non-zOS operating systems that run on the IBM Z box. But we're, of course, being this session, the first word was zOS on the title, we're going to be focusing on the zOS capabilities. So the first kind of boost that you can avail yourself of is what's referred to as a speed boost. A speed boost is allowing a machine as running an LPAR that is running at subcapacity to run at full capacity during this what we refer to as a boosting period or boost period. So you're going to be able to avail yourself of your LPAR being dispatched on a processor at full capacity, even while all the rest of the LPARs that are not experiencing a outage or a planned outage or IPLing would be dispatched still at subcapacity. So the second kind of boost that you can avail yourself of is something called the zip boost. And this allows you to, again, provide additional capacity and parallelism by allowing you to run general purpose processor dispatched workloads and on zip processors. So this is kind of a blurring of what a general processor and a zip processor are during this boost period, and I can avail myself of a larger pool of processors. So imagine I have workload in starting zOS that only runs on GPPs. During this boosting period, it can also run on zip engines as well, giving you an increased parallelism of how many processors I have available to me to be able to recover more quickly. And of course, we talked about the GDPS enhancements as well, which increase the speed of which GDPS drives the hardware actions, and as well as the speed of those underlying hardware services. Now, let's talk on the bottom left-hand corner about the boost period and how long that is. So for a given set of shutdown and startup, you have 30-minute boost to shut down and a 60-minute boost for startup and recovery of your workloads, for a maximum of 90 minutes for an individual boost. And this can be used once per IPL, twice, and if you include the shutdown and the startup as well. So this really gives you a lot of capabilities of being able to harness this extra horsepower that resides on your Z15. So now we're going to look at a pictorial diagram of this. And the first one, this red line represents what business as usual, what we are currently running with today. There's going to be some kind of a shutdown. We're going to be eventually come down, and then GDPS is going to be involved. And then we're going to restart IPL zOS, the subsystems, the middleware, and eventually return to a steady state operation. So now let's see what system recovery boost will bring to the picture. So the first item is that you're going to have some kind of event triggered, and what's going to happen is, because we are boosting the shutdown will occur faster. Notice the x-axis is the timeline that we're talking about. So we completed the shutdown in less amount of time. Next, we are then going to have a faster GDPS reconfiguration actions. And so again, that line is smaller than the previous red line up above, flat line. Next, we're going to then IPL. Now we can choose to avail ourselves of IPL by using parameters in your IEA SYS parameter, a new keyword called boost, which will allow you to specify which boost options you want to avail yourself of. And by default, you'll take all available actions that are available on your system. And so now, again, returning to steady state much quicker. We're going to be able to process that. And then the last stage here is really showing you that we're going to give you extra time. So remember, you have 60 minutes. So 60 minutes will allow you to return to steady state and to then work through that additional workload that may have built up. And so you'll have a total of 90 minutes of this boosted processors, and you boosted processors from subcapacity to full capacity, as well as having additional engines at your disposal if you choose the zip boost. All right, so this is just a nice picture diagram. So there's another thing that is a charged feature for this. So you can actually, by ordering these two feature codes shown on the right, avail yourselves of what we refer to as the System Recovery Boost upgrade, which is only available on the larger T01 machine. This one will allow you to unlock additional capacity when you need it the most. And it is just like how other capacity on demand COD offerings work. That it gives you extra horsepower for a limited amount of time. So how this works is that there are other dark engines that are on the machine, engines that are actually not running but are present on the machine. When you upgrade your machine, for example, many times we can just turn on those dark engines and now you're at a different level of machine. Likewise, we can take those dark engines that are there but just are not in use by your Z15 and actually enable them as zip engines and allow you to then be able to have significantly more engines at your disposal for increased parallelism during your shutdown, GDPS, startup, and recovery of your workloads time period. Now, this record, as it works for COD offerings, is as at the KEC level. So I have a CPC. When I enable and turn on the System Recovery Boost upgrade, I'm actually going to be able to affect the entire KEC. And so I can do boosting of several LPARs during that 6-hour window. Each LPAR can do 30 minutes of shutdown, 60 minutes of startup. But now I have 6 hours. So in theory, I could restart many different LPARs. So this might be an excellent idea if I'm doing, for example, IPLs to apply maintenance to several LPARs on the same KEC. And so I can enable that functionality and I can have this additional set of zip engines in addition to the blurring of GPPs and zips. And so now I have a whole set of engines that can run either general purpose processor work or zip work on. Just one note about this is that a lot of folks say, oh, okay, I'm gonna enable some zip engines, and this applies to both the upgrade and the non-upgrade flavor of System Recovery Boost. They say, okay, I have additional engines now to process, so I'm going to get that entire engine, right? Well, the answer is not necessarily. It still is going to depend on the priority that and the weight of your particular LPAR, and to be able to harness that additional capacity. That capacity is made available to Prism to be able to hand out, and it's up to you to fine tune those capacities on the LPAR to make sure that you're getting a significant amount of that zip engine that's now been made available. Okay, let's go to the next slide. All right, so again, the upgrade boost is priced and prepaid. Again, it activates dark engines as zip processors. There's a number of activations that you're going to buy. It has a fixed number, 30, but you can recharge it. There is a 6-hour time period, which one or more system startup actions are being performed in. You can have up to 20 zips. And a lot of folks immediately said, uh-oh, I'm going to violate the 2-to-1 rule between of what I need to have for general purpose processors versus zips. And IBM waives that rule and is not a violation during the boost period to go more than 2-to-1 ratio between zips and general purpose processors. And again, it automatically will deactivate. If you could deactivate it sooner through turning off that activation record, but it will automatically deactivate at the end of 6 hours. And there's also a 90-day no charge trial that is available if you're interested in seeing how that could possibly benefit your organization. Okay, and so to enable this base function, there's a whole set of APARs that are provided. But again, we would recommend that you just go to the FixCat and look at the System Recovery Boost FixCat. And with that particular one, you'll get all the required service that you will need. Next slide. Okay, so on the smaller Z15 T02 machine, basically one of the big differences is just that there's no upgrade boost available in the paid boost. It's only the base boost functionality in terms of the speed boost, the zip boost, and the GDPS enhanced boost. Okay, so again, depending on the model, the subcapacity models that you have for T02, you may experience even substantially higher and larger boosts, because sometimes some of these T02 machines are even subcapped really, really low. And so remember, when you do the speed boost, you go from subcap all the way to full capacity. So there could be some significant benefits for you with the speed boost in particular, as well as the zip boost on the T02 machine. All right, so that was a recap of what's been out there for a while. Now let's talk about the new Sysplex recovery enhancements. So, we really wanted to start focusing on things where we can have targeted boosts that are just beyond just an IPL. So let's talk a little bit about parallel Sysplex. Of course, we know that parallel Sysplex provides redundancy so that when disruption occurs, your workloads can continue to run. However, Sysplexes still need to recover from failures. And so when you can imagine, when the part of the Sysplex fails and your workload is still running, the execution of that workload may be delayed a little bit while the Sysplex is working harder than usual to recover from that failure that may be occurring on your system. So now there's a way to accelerate some of these Sysplex recovery actions with System Recovery Boost. And that's also available on both the T01 and T02. So again, now we can recover from Sysplex recovery actions substantially faster, and again, with no increase in your IBM software licensing costs. So IBM is not going to report this boosting period in terms of the software licensing perspective, and you'll be running at the same from a reporting mechanism. And so this is great that there will be no increase in the licensing costs. Now let's talk about what the benefits are of this. So the goals are to reduce recovery-related disruptions. So again, reducing the temporary slowdown caused by these recovery processes. Also, we want to expedite the return to steady-state operations. So by boosting, the boost period is going to shorten the length that we have Sysplex recovery that it will take. And then lastly, we want to be able to catch up faster on workload backlog. So the fact that we now have more horsepower to run the Sysplex recovery actions means that there's more resources available to run your current workloads. And number two, even when the Sysplex recovery action has completed, if there is still time left in the 5-minute time slice, they will, for a short period of time, following the restoration of that steady state operations, they will provide you a little bit of extra work to catch up from that Sysplex recovery event. So this is just great news all around. All right, now these are short duration boosts, a maximum of 5 minutes each, and you can have up to 30 minutes per LPAR per day of boosting during that time. And I was just making a joke about that. If I have 6 Sysplex recovery actions in a single day, there might be bigger problems on your system than this boosting period. So it's just kind of a humor there, but they're pretty generous of giving you up to 30 minutes per LPAR per day. There is no charge to this. There's no feature you have to buy. It's just going to be, it's built in for the Sysplex recovery actions. And again, boost capabilities are available for both speed boost and for zip boost. And of course, you have to be on the Z15 either model. So what types of recovery events are being boosted? Well, there's 4 things, and just very quickly, Sysplex partitioning recovery. Again, all the surviving systems in the Sysplex are going to get a boost as they attempt to partition workload of the Sysplex to the remaining systems. We have CF structure recovery. data sharing memory recovery, and then hyperswap recovery during the hyperswap recovery process. I'm going to cover a lot more of these in the parallel Sysplex update, and I'll talk about that in just a moment. But next slide, that's fine.
Sorry.
Sorry, Marna's driving and she's doing very well with deciding when to flip the slide. With this particular support also came with 2 other display commands. Some folks that were using System Recovery Boost, they said, you know what? It's nice that you display that information on the HMC about when something is being boosted, but I would like something in zOS to know exactly what's going on, if I'm being boosted or not, and exactly what kind of boosts I'm availing myself of. And so with this new boost display command, display IPL info boost state, we're able to show you both an IPL boost, which is the stage 1 boost that we talked about for the first part of this, as well as stage 2, which is a recovery process boost. And they even tell you which particular recovery process in the requester field. In this case, it was hyperswap. Now notice with the recovery boost for Sysplex recovery, at maximum, you can have 2 zip cores blurred. So you can have 2 zip cores that can actually handle both general purpose processor work as well as zip work. Whereas there's a much higher limit for the IPL when an IPL is being done. And this word transient, don't be thrown off by that. That's just basically that core, zip core, is now in a blurred state, which will now be able to process both traditional GPP work as well as zip work. Okay, and the next slide. And then we also have in the display m=core command, it's also been enhanced to show an engine that is currently in this transient state, which is a boost zip. So processor ID number 3 before was an I, and now for whatever reason, there's a boost going on. It changed to a transition to a B, which means that processor can handle both zip work like it used to do, as well as GPP work. And then when the boost period is over and I do this display again, it will go back to I. Next slide. All right, so in order to use the Sysplex recovery boost, you need again to be on the new z15 hardware. You should have this bundle installed from the firmware. And you need a number of PTFs. And again, like we said before, you can just use the fixcat to figure out exactly what you need. And that fixcat covers both the original IPL boost as well as the Sysplex recovery enhancements in that fixcat. So if you want to know more about System Recovery Boost in terms of Sysplex recovery, on Thursday, I'll be giving a session at 13:30 UK time, and we'll talk a lot more details about exactly the actions that are being boosted as part of System Recovery Boost Stage 2.
Okay, so thanks. We just wanted to wrap this up with a summary chart here, and I think this is a really useful chart. I keep this actually on my desk all the time. Is what you can see here on the left in the rows are all of the releases that you might be running. And then if you look at the columns, the blue columns are the required fixes that you need in order to have what we call the minimum support for the Z15. Looking over to more of the purple columns, you will see that is considered exploitation support. So the PTFs that are needed for those exploitation items are considered in that exploitation fixcat if you want. So a lot of people say, what's the difference between required and exploitation? This chart tells you, and you can see the specific functions that you have. P, PTF, Y means it's in the base, and this is also very useful when you look at W. When you see W means web deliverable, how do I acquire that? So this chart is incredibly useful, and I hope you guys like it because it takes a while to put this chart together, and I find it very useful. So I think we're a couple minutes past the hour. Thank you very much. I'd like to remind everybody to do their session feedback. I know we have some questions. Looking at them, Steve, they seem to be a lot of System Recovery Boost. So I think I'll ask you and you can answer. Okay, we're session 1AU, 1 for the gold. So please do your session feedback and also consider donating to NHS charities together as well. So Steve, let's get into the chat questions. We've got some good SRB questions on here. So from Alan, hi Alan, good to hear from you. So Steve, so with SRBU, you meaning upgrade, I believe, on the Z15 T01, which is an interesting combination. Okay, IBM is temporarily relaxing the rules on zip eligible workloads.
Right. So
Yeah.
it's for system for SRBU or for the regular SRB, which is the no charge option, during a boost period, the eligible workloads that can run on a zip are pretty much anything that can run. And so whether it's on a general purpose processor or on a zip processor, it can run on that space during that period. The difference between SRB regular and upgrade are the amount of those engines that can be available for you. So there could be significantly more parallelism if I can take all those dark engines or some of them and make them available to my processor. So I think that would be the way I would answer that question. Any other feedback on that, Marna?
Okay, no, I think that's good. That's how I would have said it too. All right, the next one, I know the answer to this, Steve, but I think I'm going to let you answer it. Philippe, our good friend Philippe says, is there a limit in the number of SR boosts you can experience per day, week, month? If there's a limit, does it apply to any given LPAR or KEC as a whole, not talking SRB upgrade here?
Okay, so my understanding, and Marna can keep me.
Yeah, I think we'll both weigh in on this one. Go ahead, you go first.
Keep me straight on this one. So we talked about certainly for the Sysplex recovery boost that there is a limit of 30 minutes per day of boosting. So that one is very obvious. So you're saying if you're a tester and you just say, shut down, re-IPL, shut down, re-IPL, shut down, re-IPL. I'm not aware of the limits, but maybe Marna, you can.
There are some limits to stop people from just doing that to try to get a total love life of system recovery boost in order to run their workloads. Those limits have not been documented as far as I can tell, and I don't think we will probably document them, but we have had limits put on that just so that someone doesn't exploit system recovery boost to constantly be running at full speed when they only are subcapacity and they don't have any license charge. So we're kind of trying to stop people from gaming it like that. I haven't been aware that we documented it like that, though.
Right, but for normal operations, that we're not going to be hindering it. I think we're trying to eliminate the edge case or abuse case.
Yeah, we're limiting on the abuse case, but if which we have not seen anybody ever encounter as just normal exploitation as well using it. So that's how I feel. That was an interesting thing early on within development of that. We were talking about gaming the system, and so there were some limits put into place just so that you don't do that. Okay, Alan again, how does the mechanism defer increases equal D software costs via SMF records, SCRT, etc.? Does it inhibit SMF record capture? So I think what Alan is asking is, how do you know that from the SMF records that we're not going to increase software costs? Steve, correct me if I'm wrong, Steve, within the software records, there is a bit that says you're during boost period, and those boost periods are not collected or gathered with SCRT. So SCRT has the smarts, SMF records have the smarts to know that you're in the boost period. So those are not counted toward your monthly license charges. Right. Steve, did you want to add more to that?
That's perfect. That's the exact answer I would have said.
Yeah, so that's why Steve can say assuredly that it does not increase software costs, because we know when you're in the boost period and we don't put that in SCRT. We don't capture that for SCRT. Does the CPC model change during the boost, requiring new software keys?
I believe the answer is no.
I believe the answer is no as well. So I don't see the model changing. Yeah. Alan again. Boy, Alan, you're our gold star questioner here. BYW. I don't know what that means. Okay, this year's talk. Okay, sorry. That was a private note. I'm sorry, Alan. I kind of read that one out loud. Sorry. From Helen to everyone. I think I'll look at who it goes to now. Does it cause a WLM policy refresh? So would SRB cause a WLM policy refresh, Steve?
No, it does not. It does not. So all this stuff is monitored I don't know, is handled internally by the OS. And from an external perspective, you're running in the, I should say what was the, let me look at you're running on the same model and you're running with the same, I don't know how to, maybe Marna, you can articulate it better. From a application perspective, they're unaware of the boost for all practical purposes.
Yeah, they are. It's all kind of done between the operating system, the HMC firmware as well. So no WLM policy refresh needs to come involved. Okay, I think that's the end of it. A lot of SRB questions, which were excellent. And we have heard anecdotally, Steve and I both have heard, right, that SRB is one of the most awesome functions within Z15. So I've heard from a lot of customers. I know, Steve, you've been there as well, hearing from customers that SRB is just a fantastic function. So no wonder that there's a lot of questions. Okay, we have a question from Matt to everyone. I think on a subcapacity model, you get a WLM message for engine speed change. That might be true. I'm not sure if you get a message from WLM. Steve, do you know if you get a WLM message to indicate that the engine speed has changed?
There might be. I'm not positive. I'd have to go check and see if that's really the case. But regardless, it's not going to affect the capacity reported. So.
Okay. And also we have a private message from Parvez that is agreeing, and Parvez is an excellent resource for a lot of the Z15 information in Europe. So he says he doesn't think that the model change occurs either, since only zips are being added.
Right.
So thanks, Parvez, for that. All right, any more questions?
Well, I'd like to thank all you guys for hanging out with us for an hour and talking about some cool things and how you can exploit your Z15 and get the maximum capabilities out of zOS on the Z15. And so we just thank you for the opportunity of always talking with the GSE UK. It's always been fun, and maybe we'll be able to do face-to-face next year. Cross our fingers, knock on wood. So thank you very much for having us here today.
Okay, thank you very much. And thanks, Anna. We can keep recording if you want. Okay, Anna, any more questions that we have? Steve and I, I'm sure, are fine to stay on as long as you want until you guys want to stop the recording. And we have our email also on the cover. If I can get back to there, here we are. Move back to the beginning, and the handouts are there. And remember, the handouts have a lot more slides than we were able to cover here, because we knew that we were going to be challenged with time. So our emails are provided here if you need to ask us any questions as well. I would like to remind everybody, because GSE is a free conference, that we do strongly encourage you to donate to the NHS charities, which are found at the end of this presentation. I'll put the slide up one more time. There's a code that you can scan, your QR code. Sorry, I'm going to go the long way through. Oh, sorry. Okay. So please consider donating generously to the charity for covering the GSE conference expenses that you might have as well here.
Okay. Well, Marna, Steve, thank you so much for this yet another fantastic presentation. Thank you guys, and thank you to all attendees who were with us today. Thank you.
Okay.
All right. Thank you
Thank you very much.
Thank you.
Enjoy the rest of your conference.
Bye.